In this presentation, The Missing Half of the Universe, we re-examine the groundbreaking discovery of cosmic expansion. At the center of Hubble's law, d equals h0 times d, lies radial velocity, highlighted here as the forgotten variable. By reassessing Vesto Slipher's foundational spectral measurements alongside Edwin Hubble's work, we uncover how these pioneering astronomers reshaped our understanding of the expanding cosmos. This slide highlights the stark divide in public recognition between two foundational astronomers. In Marshfield, Missouri, Edwin Hubble is celebrated with a dedicated memorial highway, a U.S. postage stamp, and a half-ton replica of his namesake space telescope. Meanwhile, in Frankfort, Indiana, Vesto Slipher remains virtually overlooked in his own hometown, omitted from community murals and remembered locally only as a footnote in Pluto's discovery. It is a sobering reflection on how history remembers, or forgets, its pioneer minds. To map an expanding universe, two distinct pieces of observational data were required: velocity and distance. While history widely celebrates Edwin Hubble for calculating how far away galaxies are, it often overlooks Vesto Slipher, who first measured galactic velocities, v, and proved they were moving at all. Together, their combined work completes the fundamental architecture of cosmic expansion captured in the law v equals h0 times d. In 1901, Vesto Slipher arrived at Arizona's Lowell Observatory and took on the daunting task of capturing spectra from faint, distant spiral nebulae. Using Lowell's 24-inch refractor paired with a sensitive Brashear spectrograph, he pushed early 20th century technology to its limit, enduring grueling exposures lasting up to 40 hours over freezing nights. His patience culminated on September 17, 1912, when Slipher captured the first successful spectrographic plate of the Andromeda nebula, unlocking the invisible motion of the cosmos. By utilizing the Doppler shift as a cosmic speedometer, Vesto Slipher captured the distinct fingerprints of light rather than mere star photographs. By comparing an object's observed spectrum to a stationary reference spectrum, he determined its radial velocity. Light waves from an approaching object compress toward the blue end of the spectrum, while light waves from a receding object stretch toward the red. Analyzing these spectral line shifts allowed Slipher to measure the precise speed and direction of distant cosmic bodies. In August 1914, Vesto Slipher presented revolutionary data to the American Astronomical Society. Having clocked the Sombrero Nebula receding at an astonishing 1,100 km per second in 1913, his findings revealed that almost all measured spiral nebulae were rushing away from Earth. As his dataset grew from 15 to 41 spirals by 1922, the overwhelming prevalence of redshifted velocities offered the first compelling observational evidence of a fleeing universe. A discovery that fundamentally transformed modern astronomy. While Slipher measured speeds in Arizona, Edwin Hubble leveraged California's powerful 100-inch Hooker telescope to solve the distance equation. Between 1923 and 1924, Hubble identified Cepheid variable stars in the Andromeda nebula. By applying Henrietta Swan-Leavitt's period luminosity relationship, he calculated true cosmic distances, proving spiral nebulae were distinct island universes far beyond the Milky Way. This breakthrough settled the great debate and established the distance metric, d, though mapping cosmic expansion still required combining Hubble's distances with Slipher's velocities, v. In the fall of 1928, astronomical worlds collided when Edwin Hubble visited Vesto Slipher at Lowell Observatory. Arriving under the cover of testing sites with a tiny 2-inch telescope, Hubble kept his true ambition concealed. Throughout their correspondence, Hubble never disclosed that he was actively combining Slipher's lifetime of revolutionary redshift data with his own distance metrics. Slipher viewed the visit with bemused detachment, entirely unaware that his hard-won observations were about to be synthesized to transform our understanding of the cosmos. On January 17, 1929, Edwin Hubble published the plot that changed cosmology forever. By pairing his calculated galactic distances on the x-axis with Vesto Slipher's precise velocity measurements on the y-axis, a clear linear relationship emerged. The resulting slope, the Hubble constant, h0, proved a profound cosmic truth: the farther a galaxy is, the faster it recedes. This iconic graph provided the definitive proof that our universe is expanding. While Edwin Hubble's 1929 landmark paper transformed cosmology and cemented his legacy, it concealed a profound breach of scholarly protocol. Hubble plotted 24 galaxies in his graph, drawing from 46 nebular velocities known to science at the time, 42 of which had been painstakingly measured by Vesto Slipher. Yet despite using this vital observational dataset to prove cosmic expansion, Slipher's name was completely omitted from Hubble's publication, marking a silent injustice in scientific history. Why did history credit the expanding universe almost entirely to Edwin Hubble? The answer lies in a clash of personalities and institutional power. Vesto Slipher was a modest astronomer at the small, underfunded Lowell Observatory who used a 24-inch refractor to discover cosmic velocities. Meanwhile, Hubble was a charismatic figure at elite Mount Wilson, wielding the powerful 100-inch Hooker reflector to calculate cosmic distances. While Slipher proved galaxies were fleeing, Hubble's institutional clout and flair for self-promotion ultimately eclipsed Slipher's vital foundational contribution. Beyond scholarly omission, institutional jealousy from Mount Wilson spawned condescending folklore to undermine Slipher's achievements. A persistent myth claimed Slipher succeeded only because, as mayor of Flagstaff, he held a master switch to douse the town's streetlights at will. In truth, Slipher was never mayor, and no such switch existed. This fabrication painted him as a petty small-town tyrant, dismissing his true breakthrough. Sheer technical ingenuity and mastery of the Brashear spectrograph. Modern science recognized the need to dismantle Hubble's solitary monopoly on cosmic expansion, yet the true observational pioneer remains forgotten. In 2018, the International Astronomical Union voted to rename Hubble's law to the Hubble-Lemaitre law to honor Georges Lemaitre, who mathematically predicted cosmic expansion using relativity in 1927. However, by prioritizing theoretical calculations, the scientific community once again bypassed Vesto Slipher, the observer who provided the foundational, empirical proof of fleeing galaxies as early as 1914. Because the fundamental equation of cosmic expansion relies on both distance and velocity, justice demands that the parameter binding them honors both pioneers as the Hubble-Slipher constant. Even Edwin Hubble ultimately acknowledged this debt in 1953, the year of his death, admitting that Slipher worked almost alone to supply 42 of the 46 known nebular velocities and calling his early work by far the most important of all. To truly complete the story of cosmic expansion, history must finally give Vesto Slipher his rightful place alongside Hubble.